Welcome, everybody. Thank you so much for joining us today for the Introduction to Air Barrier Systems AIA presentation with Nicholas Tam. My name is Isaac Sorensen. I'm the National Architectural Sales Manager with WR Meadows based in the Northeast in the New York City metro area. Thank you for joining us today for our monthly public AIA series presentation today, Introduction to Air Barrier Systems. So our presenter today is Mr. Nicholas Tam. Nick is our Dallas-Fort Worth-based dedicated architectural rep and servicing a large Southwestern and Central territory for WR Meadows. Before I pass the presentation over to Nick, I want to go over a few things together. Also wanted to put in a plug for our next presentation that'll be held on the third Thursday of next month. Presentation on basics of moisture movement through the building envelope. And just before we begin, a little housekeeping before we get started. Everyone will be muted for the duration of the presentation. If you have questions, please type your questions into the Q&A box and double check that you're addressing your questions to all panelists. And we will be monitoring the Q&A and we'll be attempting to answer your questions in real time. However, if your question requires a lengthier explanation or is a bit more complex, we may hold on to them until the end of the presentation to answer verbally. We also may need to get in touch with you afterward via email for a longer explanation. So this is an AIA accredited presentation. Everyone will be receiving certificates sent to the email address you provided to us at registration. And if you included your AIA number, we will be submitting these credits directly to the AIA. Lastly, on the screen, you'll see an email address at some point during the presentation and afterwards, info@wrmeadows.com. If you would like a copy of the presentation or would like to get in touch with your local rep or have additional questions for us in the future, we look forward to you shooting us an email, info@wrmeadows.com, and we'll certainly get you whatever you need. At this point, I want to turn over the presentation to Nick, and take it away, Nick. Thank you so much.
Alrighty, thank you, Isaac, and thank you everybody for joining with me today and allowing me the opportunity to present to you all. As Isaac mentioned, my name is Nick Tam, and I'm the architectural specialist here in the Southwestern region. I reside in Fort Worth, but I cover a lot of the area surrounding Texas as well. And without further ado, we'll go ahead and get started. So a little background on WR Meadows. We are a manufacturing company of Division 3 and 7 materials, and we were founded in 1926 in Elgin, Illinois. Ever since our founding, we still are single family and privately owned and operated. But with that, we are continuing to grow throughout North America. Currently, we have 12 facilities with 2 in Canada. Our work isn't just limited to North America, though, as we do have a lot of work internationally as well. Originally, we started out as a company manufacturing asphalt expansion materials, but later on we started to branch out, and then we later on started making concrete restoration products. This would be your repair mortars, construction grouts, and epoxies. And then we started going into construction liquids, which will be your curing compounds, acrylic sealers, and penetrating sealers. We also manufacture joint sealants, which will be from polysulfides to polyurethanes, as well as asphaltic polymeric compounds for crack filling. For the bulk of our presentation, though, we're going to be focusing on one area of our building envelope, which will be air barriers. But we also manufacture below-grade waterproofing, as well as under slab waterproofing and vapor retarders. We do have a sister company called Blue Ridge Fiberboard, and they're going to be for your acoustical materials. This will include sound dampening, as I've been told it's actually called, and insulation board as well. As Isaac mentioned, this is an AIA accredited course, so everyone in attendance will receive 1 learning credit for their attendance today. So to go over the objectives, today we're going to talk about moisture movement and all the different types, as well as all the potential issues that do come from this unwanted moisture movement through our structures. There are a variety of products out there that help us be protected from this moisture movement, and we're going to identify all the variety of products out there. With products, though, we do have to integrate proper design. So we're going to talk about those different design options, as well as the best practices when installing these products onto our structures so that we can have a very well airtight structure. When discussing the building envelope, we don't want to take into account just one side of our structure. We want to take into account all six sides, which is going to include the underslab, the below grade, as well as our above grade systems. The science of moisture control considers the entire building envelope. So, in other words, we have to make sure that we are fully encapsulating our structure, which is going to require segmentation and proper sequencing from all these different systems. If we don't have proper segmentation, even just one little area without that proper transition, it can cause a lot of problems for our structure. And when you look at this, these are just a lot of details to show how the sequencing takes place. As you can see, it's not a matter of just slapping a membrane on the wall and calling it good. We have to make sure we have proper sequencing with all the peripheral systems, which can be from walls to windows, the below grade to above grade, as well as the roof to wall transitions. And we'll expand on all this a little later in the presentation as well. A high performance building, by definition, it can be defined as a building that integrates and optimizes on a life cycle basis all major high performance attributes, which includes energy conservation, environment, safety, security, durability, accessibility, cost benefit, productivity, sustainability, functionality, and operational considerations. It's one heck of a long run on sentence from the Energy and Independence and Security Act of 2007, but it holds true to what we do want for a high performing building. And for when it comes to air barrier systems that we're focusing on today, there's really four categories that we really focus on as it relates to a high performance building. And that's going to be the energy conservation, the durability for the sake of the lifespan of the structure, the productivity of it and all those who occupy it, as well as the operational considerations when you think about all the systems that are used to make sure that we are conditioning the structure properly. But before we talk about air barriers as well as all the perfect design aspects, we do have to go back into our third grade science lesson and understand how moisture movement actually occurs on our Earth. So we start with the hydrologic cycle. This will be where we have our large bodies of water that are going to heat up and then evaporate and start condensing into clouds. Afterwards, we get precipitation, which can be in the form of rain, sleet, snow, or hail. And it falls back down to our earth, but will make its way back to the large bodies of water so that the cycle can repeat. When we're building our structures, we actually are disrupting this process. So moisture will want to find its way through our structures so that it can get back to those large bodies of water. So this kind of highlights why it's critical that we have these moisture protection systems. Then we have gravity, which is pretty self-explanatory. Any moisture that's fallen towards our structure will find its way through any opening or crevice. And we also have capillarity, which by definition is simply water that rises against gravity. I think one of the best ways to kind of explain this is think of a paper towel. If you were to dip a paper towel into a little tiny thing of water, you'll actually notice that water starts rising into that paper towel, and that's due to capillarity movement. And how it works is that there's a lot of small little openings in that paper towel, all these little fibers that are working together. And because it's absorbing that water, this is an example of capillary movement. And the smaller the fibers or the smaller the openings, the more water is going to rise up against gravity. The same can be said with any building material we use to make up our walls. It could be a concrete wall or it can be sheathing. They're all going to have some form of permeable ability or porosity that can cause some capillary movement. We also have vapor diffusion. This is moisture in a gaseous state's ability to move directly through a building material. In this case, we have a piece of sheathing wall, and moisture from a vapor state is moving directly through it. And then we have air transportation, which is the same piece of sheeting board, but with a 1-inch hole. And we have air now having easier access from the exterior conditions, being able to move directly through that piece of building material. And then we have to discuss the dew point, which by definition is the temperature at which moisture can no longer be held in a gaseous or vapor state. It condenses into an actual liquid water on the surface. So we've all seen a Coke can being taken out of the fridge, and when we place it outside, we start seeing moisture bead up on the side of that can. The reason being is because the can is going to be at a temperature that is below the dew point temperature. And with that, any vapor content that's outside is going to start condensing into a liquid onto the surface of that Coke can. So expanding on moisture movement by air, when we think about transportation, it really counts for 70 to 90% of the moisture movement, whereas the diffusion will only be about 10 to 30%. So looking at the example on the left, this is going to be a hot and humid climate where we have an interior conditioned space of 70 degrees and 40% relative humidity. So that interior space is going to be the area of lower pressure, whereas the outside is going to be of higher pressure. Because of that pressure difference, we have diffusion directly through the building material here, and we get about a third quart of water. While it doesn't seem like a lot, we can take that same piece of sheeting board and multiply it times 100 pieces that are going to be used to make our structure. When you think about that, that becomes a lot more water. Now moving to the example on the very right, we'll take the same piece of sheeting board, but we're going to punch a 1-inch by 1-inch hole into it. Now the transportation of moisture or air from the outside moving directly to our structure is with much more relative ease. And because of that, now we're getting 30 quarts of water. So a lot more critical, and it really kind of highlights why we have moisture protection systems as air barriers as well. In discussing air leakage, it's really not a matter of just if we have a 1-inch hole in our structure. The fact of the matter is there are a lot of building components that are going to actually make up the building envelope. What this means is that we're going to have a lot of different areas where the building components are connecting, which is creating a new access pathway for air to leak through. If we don't take it into account or try to protect our structure from this, we do get bulk air leakage, which is shown on the picture on the right. And what happens is any conditioned space from our interior side is going to be displaced from the conditions on the outside of our structure. In this example, if you take a cold climate, we have a heated interior space. Well, with any type of air leakage, especially in excess, that warm air is going to be displaced by the cold air on the outside, and we have our HVAC systems having to continuously run. It's got to be noted that any HVAC system that's conditioning our interior space, they do have a lifespan of their own. If they're continuously running, trying to maintain that interior space condition, well, we're decreasing the lifespan of it. And more importantly, we're also increasing energy costs. And we also have to take into account is when you get a lot of air leakage, we are potentially moving that dew point that we mentioned earlier from the outside and moving it to the interior side where we can start seeing condensation. With condensation, we can get potential rot of any wood, we can get corrosion of any used metal or any type of steel, and it becomes a structural integrity issue at that point. And in discussing air leakage in and out of our buildings are going to be caused by pressure differences. And this could be from wind pressure, stack pressure, as well as fan pressure. When looking at each of these independently, wind pressure occurs when wind blows against a building and causes a positive pressure on one side with a negative pressure on the other side. Holes in the building can cause infiltration of unconditioned air on that windward side and exfiltration of conditioned air on the leeward side. And so this is just to show that with wind, it actually does cause differences in pressure as well. Stack pressure is going to occur specifically like in a cold climate when warm air is rising, or more correctly, cooler, dense air is sinking. Again, with an air barrier that isn't continuous, stacked pressures can actually cause exfiltration at the top of the building with warmer, moist air and infiltration of the cool air that happens at the bottom. If we're in a summer or warmer climate, these pressures can actually be opposite of each other. When we talk about fan pressure, this is actually going to occur from mechanical systems that draw air throughout the building, creating both positive and negative pressures within the structure. Because of this, we will get both infiltration and exfiltration. This is where we'll see things like a plenum chamber, which is essentially a type of ventilation or air transfer system that will facilitate airflow throughout the structure. So with air leakage, in theory, it should be pretty easy to deal with, right? We fill in any gaps or cracks and make sure that everything is monolithic across the structure. But in practice, it's easier said than it is done. Looking at this picture on the right, this is a real project where behind the facade, this was uncovered. And if you can guess, this building is definitely not up to code, and it really becomes a critical structural integrity issue at this point. So I already mentioned earlier about HVAC systems having to overrun in terms of trying to save energy costs, but also we don't want to waste energy as well. And I mentioned condensation that becomes a structural integrity issue. That will relate to the life cycle of the structure, and we want to make sure that we can increase the life cycle of that structure as much as possible. But we also have to think about the overall function of the structure. Anybody who's occupying it, you want to make sure that they're having their comfort and their health taken into account. I think the COVID year was a good example of this, but we have to think about the fact that if you're occupying a structure and this HVAC system's having to continuously run, we could potentially letting outside toxins enter our structure. And also, I want to be able to work in my air conditioned building without having to take off articles of clothing because it's still too hot. And lastly, the last person you want to be is the gentleman being pictured here on the right, having to be interrogated. And the reason we show this picture is because, according to AIA, water infiltration is a leading factor in post-construction litigation. These are just some photos that are going to show some of the issues that can arise due to uncontrolled airflow and the moisture that is associated with it. If you notice on the top left, you can see some corrosion of metal components. And in the bottom middle and top right pictures are really good examples of rot and mold. And then you also have to think about the degradation of components. It's not about just what's inside of our wall. You also have to think about the facade and the exterior side. The middle picture, bottom left and bottom right are really good examples in cooler climates where you'll see moisture that is actually becoming an issue and causing deterioration of the brick facade. And this can all be due to just improper detailing and not taking into account of how continuous this membrane should be across the board. And according to NB Hutchins, air barriers cannot be dealt with without understanding that they are part of a wall assembly. An air barrier membrane, it is an important part, but like I said, it's just a part. We have to understand that there are a lot of different building components that are going to make up the actual wall assembly, and they have to be able to work in conjunction with each other to ensure that we have proper segmentation and proper continuity. In expanding on the building enclosure basics, we start with our backup walls. In this case, we have a CMU block wall, and then we follow with the 4 control layers. What appears here is a liquid membrane that's going to have 3 control layers of a water control, air control, and a vapor control. And then it's going to be followed with some insulation that serves as our thermal control layer. And lastly, we'll finish off with our cladding, and that alone is going to make up our building envelope. This is an example of a lower costing wall that we see a lot in our projects today. This is going to be a steel studded structure with a sheathing attachment. But with this, compared to the CMU wall, one thing that will lack is the moisture sink that can be provided by the concrete block. but we still follow up with those 4 control layers like we would on the other backup wall, and we still have what we call a really good building envelope here. A question that really comes up even to this day, and I don't anticipate it really going away, is where is the air barrier located? And really, the cheeky response that we can provide to this is that it's going to depend. What it depends on is your hygrothermic region. It's going to depend on local codes. And it's also going to depend on the values of all the building components that are making up the wall. This can include the type of backup wall, the interior finish, the type of insulation we use, and really just what kind of vapor drive we may see in, or what kind of pressure difference we may see. So really, this is an introductory presentation, so we won't dive too much into this, but we want to point out that overall, where the air barrier is located, it is going to depend on a variety of factors. But the essential elements of what makes an effective air control layer, we want it to be airtight, obviously, but we also want it to have waterproofing capabilities. We don't want it to be absorbed directly through, because if it does, then we're really defeating the purpose of it, aren't we? Then we also want to make sure that it is continuous. This means that all joints, laps, and seams, they do need to be airtight, and we don't want any breakage in that as well. For durability, we don't want this product, whatever is used, to have to be maintained over a variety of different periods of time of the structure. It should be a one-time application that does not require a lot of maintenance. And for structural integrity, our buildings move, right? We're always going to have something that alters the way the building contracts and expands. With any structure material that we use to protect our building from moisture or air, we want to make sure that it can also expand and contract with the structure, as well as have good recovery. For the layers in an air barrier system, as I mentioned earlier, an air barrier membrane, it is an important part, but it is just a part of the actual air barrier assembly, as well as the air barrier system. With an air barrier membrane, we also have our joint sealants that we use for, say, sheeting joints and expansion joints that will make up our air barrier assembly. But they do have to work in conjunction with our fenestration systems as well. So this will include your glass of the window, flashings that are there to treat the rough openings, and your mastics and sealants that are going to help seal any joints that meet the window assembly to the actual wall. When these all work together, this in turn is going to make the actual air barrier system. We have to make sure we protect from air on all 6 sides of our structure. We're not just protecting it on the vertical side. So when everything works together, we're going to have a really good airtight structure. And another question is that we see a lot is, do you need a vapor barrier in the vertical wall assembly? Well, the short answer is no, you don't, but it still diverts back to what I said earlier. It depends. Again, it's going to depend on your hygrothermic region, any local codes, as well as the values of all the building components that make up our wall. A lot of good examples out there to show that there may be some materials that are just strictly for air protection. There may be a material that has an air protection layer and your vapor protection layer. Looking at the example on the right, which is an example of a flow-through assembly, we're using a vapor permeable building paper. And this is going to be qualified as your air barrier, but it wouldn't constitute as your vapor barrier as well. On the very right, we have an example of what is some considered the perfect wall. And in this case, we have a CMU backup wall, but it's receiving a vapor impermeable layer that also acts as our air barrier and our water control layer. Lastly, it's followed up with rigid insulation. But like I said earlier, this is going to depend on those factors that I mentioned. So this is an introductory presentation, as I mentioned earlier, so we're not going to dive too much into that today. So now we're going to get into the fun part of the presentation, right? what type of materials are out there. And so we'll go over all of these materials in the next several slides, but we talk about sheet membranes, mechanically fastened membranes, spray foam, and fluid applied membranes. And I'll go over the qualities of each one here in just a second. So for sheet, oops, pardon me. So for sheet membranes, we see self-adhered sheet materials that are used commonly in our market. These are dedicated air and moisture barrier systems, and they do come in permeable and impermeable makeups. For your impermeable membranes, they will require a primer due to the rubberized asphalt makeup of a lot of those materials. That asphalt needs to be able to bond to the substrate, and this is where primers are going to be used. For your permeable membranes, for a lot of manufacturers out there, they're not going to require a primer. So a bit of an added benefit there as you're eliminating an accessory. But a lot of people ask, what is the point of using this when there's other materials such as fluid? Well, with self-adhered sheet membranes, you're getting a controllable thickness, and they're not going to be at the mercy of the subcontractor to install it at the thickness that we need. And so really when we observe these materials on a job site, we're really just trying to make sure that they're detailed appropriately and that they're smoothly applied without any breakage or any folds or wrinkles. But then we have fluid applied membranes. One of the products that we see quite a bit in the market, especially here in the South, but these are products that can be installed in a variety of different applications. Really good benefit when you think about a CMU wall there on the very left that has brick ties already installed to it. With fluid applied membranes, these are going to be able to be installed directly over it, so it does offer simplicity depending on the type of makeup of wall. Also, an added benefit is that these materials will cover a large area of square footage in a short amount of time. And with that coverage, which is a good example in that right picture, is that we don't have a lot of detailing that really needs to be done. But with the simplicity of this, there is some complications that can arise, particularly we're putting the mill thickness at the hands of the subcontractor. And so we may get some inadequacies as far as that mill thickness. And with the mill thickness, whether it be too thick or too light, it does affect the performance value of that material. And when we think about asking project superintendents to monitor this, asking them to measure every square footage of that air barrier on the project, usually not going to happen. And so we really had to make sure that we have quality assurance on this, but also make sure that this contractors are going to be well trained on these type of materials. Then we also have insulating board stock or integrated sheathing. These do qualify as air barriers as a general term. One thing to note is on the picture on the left, we do have to make sure that those board joints are treated for it to qualify as an air barrier. But it's also important to note that when we talk about those 4 control layers earlier, with materials like this, if we do have any damage to that insulation layer that's acting as our primary air control layer as well, we're in effect hindering all 4 control layers at that point. So this is typically why we do see a lot of dedicated air moisture barrier systems behind insulation, so that we can at least have protection of 3 out of the 4 if the thermal layer is going to be hindered in any way. And then we also have mechanically fastened membranes, or for what we see on a lot of projects, building wraps. And they're a really good economical choice. We see this a lot for wood frame structures, whether it be a multifamily or a residential project. But unlike our fluid applied and our self-adhered membranes, one thing that has to be taken into account is that this material is not fully bonded to the wall. So with any moisture that may get behind this membrane, it will run down the wall. And if we're trying to pinpoint the leak, it really is going to be a challenge at that point. And so this is why we see the benefits of self-adhered or fluid applied membranes, is because if there is a leak, we can usually pinpoint where they are. Also note with materials like this is that I mentioned wind pressure earlier. Well, if we're in a project in West Texas where it's continuously windy, there is a potential that this material can be lifted up a little bit with more ease and it can become damaged. And with that, we're going to have replacement costs, and it's going to be a little bit of a scheduling issue as well. And then we have our foaming fluid applied materials. So what we consider the holy grail, because it's a little bit of your do it all. It's going to waterproof. It's going to provide thermal resistance, especially when it comes to wood frame structures. And it's also going to be in either open cell or closed cell as it relates to the permeability of the material. So a really good product to use, especially when we think about wood frame structures, not used as much with steel just due to thermal bridging, but with them, they do come at higher cost, but depending on the budget of your owner and the makeup of your structure, these could be a really good option. So which of these is not an air barrier material? A little pop quiz for you all. I'll give you about 3 seconds and then I'll go ahead and answer. Well, this Jif peanut butter and the gum wall, they look pretty suspicious, right? But surprisingly, everything here will qualify as an air barrier. When we look at specific codes, such as the International Building Code, they're not going to take a hard stance on what actually is going to qualify as an air barrier. And what I mean by that is it states that anything that stops the flow of air from entering our structure, in which all these materials can do that. But what they're not going to take into account really is it going to have waterproofing capabilities? Is it going to have those tensile strengths or elongation factors? Is it going to have flexibility and good recovery should the building move, contract, or expand? Also, we think about UV exposure. Every product has a limit, and some of these products may not be able to be exposed to UV for a long period of time. So, what the point of this is really just to show that we have to really do some good investigation to decide which material is going to be best for our project and not just rely on the code itself. So let's expand on the actual components that make up the actual air barrier assembly. So aside from the primary membrane that we will see, we also have transition membranes. So these transition membranes are going to be there to bridge any gaps that are interrupted on the backup wall. This could be a situation where we may have a gypsum sheathing wall meeting a CMU wall. And because of that, we have a new joint and it will have to be treated with a transition membrane. We may have an old build or a new building being constructed directly against an old building. And with that, we have to bridge that gap. But then we'll also have our tapes. These could be mesh or peel and stick membranes. With these, they're going to be utilized with fluid applied air barriers. Reason being is because fluid applied air barriers are not going to bridge those sheathing joints as well as your normal sheet applied membranes. And so because of this, you'll see a mesh which is integrated with the actual air barrier, or they'll see a peel and stick that's going to be installed prior to the primary membrane. Then we have primers, or in some cases they're called adhesives. These are just there to make sure that any self-adherent peel and stick membrane can bond directly to the substrate. With mastics, or termination sealants as I call them, they're going to be there to seal off any edges of those peel and stick membranes because we don't want them to peel up and have a chance for anything to get underneath. Also, for any overlapping of those membranes, they do have to be treated as well so that we can maintain that continuity that we mentioned earlier. For joint fillers and patching compounds, you think about expansion joints. You also think about those sheathing joints that I just mentioned earlier. We have to make sure they're filled. And so whether it be a liquid compound or a sheet applied material, we have to make sure that we are sealing those gaps as well. And for patching compounds, you think about a sheathing wall meeting a foundation wall. Well, with that concrete, if it's not going to be very smooth, we have to make sure that this membrane can adhere to it, right? This is where those patching compounds will come into play, and we smooth out the surface so that we can make sure that these membranes have 100% bond and there's nothing jeopardizing that bond. So for product considerations, and this is really considerations when we talk about the type of product that we want to use, we have to look into a variety of factors, and one of those factors will be the product durability. We want to make sure it has a good track record of history. We as a manufacturer can tell you how great our product is, but if we don't have any proof showing that this product has been used in the past, are you going to take our word for it? Also, we want to make sure that it is meeting local code requirements. We know that with a variety of different hygrothermic regions, there are going to be specific codes that relate to them. Also, when it relates to cost, it's not just going to relate to the material alone. The material is going to help dictate the labor that it takes to install it, as well as the time it takes to install it. And so we all know that labor costs money, and we know that if we extend the schedule of our project, that can cost money as well. So we had to factor all this in together. For any manufacturer, they should have field representatives in some manner. And with that, we want them to be a resource for you all. When they are in the field, they should be able to be on call so that they can answer any questions as it relates to installation of their products or how that material should be integrated in the design. So for compatibility, we have to talk about the compatibility between one system and another system. So this could be related to the roof system having to transition to the air barrier material on the wall. If they're not compatible, we'll have issues. So we have to make sure that we select materials that will work together. Also, when it comes to the project and site conditions, this can relate to your climatic region. This can also relate to what's surrounding your actual project. I think a good example of this is if you have a project that's being constructed in the middle of a downtown city, and next door we have a parking lot. Well, if we're using a fluid applied membrane in this situation and we get enough wind built up, there is potential that this material can spray over and land on some of those cars, and it becomes a problem. So that might be a situation where you'll say, well, we'd rather opt for a sheet applied to avoid that issue. For rainfall resistance, there are materials that may require a few days of no rain to make sure that it does not hinder its curing ability, especially when we talk about fluid applied membranes. Also, you want to make sure that the substrate is not wet when installing any sheet applied material. For puncture compensation or self-gasketing, we talk about ASTM D1970, which relates to the self-sealability of any type of air barrier material. We have to note that it is a little overly presumptive, but with any puncture that may present itself, we want this material to be as resistant to that puncture as much as possible so that we don't have any critical errors on our structure. So we just discussed the types of products that we may want to pick, but now we want to go into the actual specifications where we start listing products. When we get into construction documents, we want to list products, and we usually will see a variety of different manufacturers that are going to be listed for the intent of selecting a product that's going to meet the purpose of our structure. So we try to meet performance reports. Most common specifications we see are ASTM E2178 and E2357 as they relate to the permeability and leakage of those materials. When we select materials, is this going to be a proprietary or performance-based spec? With proprietary, we may see one manufacturer's product listed and then a variety of products listed after that that are similar. But a lot of times we do see performance-based specs where we'll just see a list of multiple products that are going to meet this performance standards. But one thing we do have to note that if we are trying to meet performance standards, make sure that whatever product from a multiple manufacturers, that they're all going to be as similar as possible and that they do hold the specification. The reason I bring this up is because there are a lot of different products that are going to serve different purposes, but they'll all still meet the same performance standards that we may want on our project. If you're wanting a medium build air barrier for your structure, but you list a bunch of products that are only going to meet specific performance standards, you may list a medium build air barrier from manufacturer A, you may list a thin mill barrier from manufacturer B. Well, if we do that, more than likely you're just going to have your subcontractors bidding with the thin mill system because it's lower cost. But if you're wanting a medium build, then we threw that out the door. So definitely research your products. Also, when we talk about compatibilities again, there are times where we will see multiple manufacturers having to supply the materials for one air barrier system to work in conjunction with each other. If we do that, we do have to ensure the compatibility between the two, because if we don't, and there's issues on the project, You're going to have manufacturer reps coming to the job site, potentially pointing the finger at each other, trying to figure out who's actually at fault. And then when we design our air barrier systems, we just want to keep it as simple as possible. Looking at the picture on the right here, we have a variety of different materials that are all working together to act as the single air barrier. And with this can cause a lot of confusion as well as incompatibility issues depending on the makeup of these materials. And we also have to think about the transition points. The stairs that are meeting the wall right here creates a little bit of a challenge in trying to make sure that we have the continuity of the membrane and keeping it all monolithic. Also, we do want to pay attention to how many penetrations there are on the wall. The reason why is because if we have a lot of them, we don't want any of them to be missed, and then we want them to be transitioned with relative ease. If you see a cluster of penetrations, that's usually when it becomes a problem because it's hard to seal in between each penetration. Where penetrations are unavoidable, we at least want to make sure that we do develop details that are going to be clear and that they're simple to construct. Because if we don't, then we may just leave it at the subcontractor to find the best means of method to try to seal it. And that's not always the best solution. And so when we go through the design and install process step by step, we start with the process of drawing the air barrier. The saying goes that the designer should be able to trace an air barrier around the entire circumference of the building, especially the entire area that's encapsulating the conditioned space. That is important, but proper detailing is also necessary. It's ideal if the designers can take the time to draw the joints, all the corners, and the meaning of different materials. Best of all, the team should meet for a plan review on the air barrier assembly. Without this kind of detailing, too much is left to chance and to the abilities of the installer. And if we have a third-party inspector or we have anybody that's going to observe the job site, they're going to be able to point out mistakes, and that can result in change orders. Also, we have to think about the tricky parts, the roof to wall, foundation to wall, anywhere we're having different types of connections from different systems. Looking at these two pictures, I mean, talk about joints, right? There's a lot of different joints here, and ultimately, are we providing an ease of segmentation between all these different systems? I think the picture on the right is a really good example of where we have a lot of window openings, we have a lot of different building materials, and we have an awkward set of joints that I don't know if the contractor was going to be able to get good accessibility to that joint to ensure that we have the proper segmentation that we need to have an airtight structure. So we want to make sure that we have proper segmentation when possible, but we're also not going to tell you to not use your imagination and create the beautiful artwork that is these structures. Also want to note that pre-installation meetings, these are a must. They're not only a must for your trades that are going to be on the project, we also believe that any manufacturer reps and materials that are going to be used, they should be involved in these as well. This is going to be especially true when we talk about compatibilities, because for an air barrier system, there are a lot of different trades that are going to come into contact with these systems. We have our backup walls, sheathing, or anything like that. Whoever's installing that, they need to understand how the profile should look before the air barrier goes on, as well as take care of any issues that could cause an hindrance in the air barrier quality. We usually use ASTM C1280 to relate to this as it relates to the quality of the sheathing being installed. But we also have to think about the facade contractor. When all of these can come together in a pre-installation meeting, we can discuss the proper sequencing and scheduling so that we can prevent any potential issues. Also, mock-ups are very important in these pre-installation meetings because it's not a matter of just seeing how pretty it's supposed to look. We want to make sure that we see all the segmentation. We want to know how the segmentation looks before we start it on our actual wall. This also helps us make sure that we can see where the incompatibilities may arise and come up with a solution right then and there. And really, just to kind of hammer in what we were already mentioned earlier, for installation considerations, we have to make sure that these substrates are prepped appropriately. we have to make sure we take into account the number of joints as we decide what materials we want to use, because there are materials out there that may be installed more easily for a large square footage structure compared to another product. Also note that your environment and your hygrothermic region can alter how well a specific product might perform, specifically fluid applied versus a sheet applied. Also, when you take into account the number of penetrations, we also had to note that if there are a lot of penetrations, we want to make sure that they are easy to access as far as making proper transition from that penetration to the wall. And kind of expanding a little bit more on the substrate conditions, one thing that can really alter performance of any air barrier that's installed to it is potential moisture content. When you think about concrete and CMU block, they're going to be able to absorb moisture. And so if we have a big rainfall event and the moisture content is still inside of that concrete or CMU, it can actually inadvertently affect the air barrier, especially if fluid applied if it's installed. And the reason I mention that is because if we get enough vapor drive through those CMU walls, considering how permeable they are, we can in turn start getting bubbling on the air barrier and it becomes a problem. So we want to make sure that these substrates are as dry as possible so that we can prevent any of those issues. The same can happen with sheet applied materials, but do note that we try to keep any surface as dry as possible. Also, we have to think about which product is going to be best for the type of joints we may have. Some joints may be too large. If they're greater than a quarter of an inch, it may be a situation where we have to fill it in a different manner than we normally would. And for any connections, if we think our building is going to expand and contract, let's think about how it's going to contract if we have another component coming in connecting perpendicular with it. For any material that we use to make the transitions between these connections, that material needs to be supported as much as the actual air barrier material. And what I mean by that is with any air barrier material that's for your primary wall, its expansion and contraction features need to be the same as the transition membranes. So we want to make sure that this structure is as durable. The air barrier needs to be as durable with it as well. And then this is just a couple details. It may be hard to see, from a computer screen, but what we like to show here is that these are good examples of the segmentation that we need for our structure. With the example on the right, what we have here is that a fluid applied membrane going on the wall, but we have every joint being treated with a proper peel and stick membrane. That concrete beam meeting the edge there is being treated with a transition membrane from the wall going over the entire concrete slab, going to the other of the wall, and we're treating the edges of it, keeping it monolithic. We also have the roofing membrane actually encapsulating the very top, and we're also making sure that we prevent any moisture creep from underneath. So this is a good example of good segmentation, but do know that there are a lot of different methods that can be used to create a good encapsulation of our structure. For penetrations, we want to make sure we don't have any unnecessarily large holes. We also want to make sure that we can treat the penetration with relative ease. Looking at the picture on the left, you can see that the peel and stick simply isn't going to cut it, right? It's not going to gasket it. It's not going to provide a full seal around the uniqueness of that penetration. So we like to refer to the acronym UMP, which is use more Pookie. Goop it up, make sure that we're getting as much around it as possible so that we can get a full effective seal. One thing to note is that in the top middle picture may be a situation where gooping it up is a little bit more of a challenge. So we may opt for something else that to fill that hole. A good example here is using maybe an SPF foam to fill that in because it will aid in the transition around that penetration. We spoke earlier about self-sealing membranes and how no membrane can really self-seal around dozens of screw holes. But with screw holes that are being driven, we do want to make sure that it does have the ability to at least resist any potential infiltration. But one thing to note is that with ASTM 1970 in E331, These are going to be tests that relate to materials in perfect conditions. But are we really going to rely on the potential self-sealability for thousands of penetrations going through a wall? More than likely, that's not going to be the case, and we'll typically see particular treatments of these fasteners going into the membrane or on top of these fasteners after it's already been installed. Some good examples here. For the top left, I mentioned earlier about how with a CMU wall with brick ties sticking out that you can just use a fluid applied membrane being installed directly over the top of them. It will seal it, but in some situations, we may have a sheet applied membrane be installed first, and then they'll install the brick ties directly over that. While we could think about the self-sealability potential of that membrane, you can see here that we're still treating over the top of it with the appropriate mastic. And so this is really a good security measure, and it doesn't require too much material to achieve that. And then there's going to be some penetrations where spraying over the top of it may not be the best option. You look at it, the strips here. Well, if we spray over the top of it, more than likely we're going to miss somewhere behind it, and becomes an issue with potential areas that we may not see gaps in the membrane. So definitely consider what type of ties are being used in deciding if we are going to spray over or if we're going to install after and have some way to gasket it. For shelf angles, really nothing too complicated here. Ultimately, we just want to show that we are treating the shelf angle as part of the wall. And so we still have to have proper transition on those angle irons as well. So from this example, we have a peel and stick membrane transitioning from the sheathing wall directly on top of the angle iron. And while you don't have to necessarily have it cover the entire angle iron, we want to just to make sure that any moisture that's touching our system is going to be able to be channeled out and away from our structure. Underneath, we still had that transition as well, and we really treat these the same as our window openings. In some situations, we're going to have different types of transitions at the base of wall. From the left, here is a very simple situation where the facade is going to leave some of that foundation exposed, but where that wall meets the actual foundation, we have a joint. And so we'll typically use a 6-inch piece of flashing to transition over that joint and have the primary membrane shingle on top. But in some situations, it can be a little bit more complicated. So that's where we'll opt for the area on the right, where we'll start from the bottom with a below-grade waterproofing membrane, encapsulating the foundation, but transitioning to the above-grade backup wall. In turn, then we'll have the transition membrane shingle on top of that, channel out at the weep, and then we'll have finished off with the primary membrane on top of the transition membrane. People have asked us why we have the grout fill here. The reason being is because with the high weep, we want to make sure that we can transition towards it. And if we don't have the grout fill, then we have a lot of empty space there that's prohibiting 100% bond of that transition membrane. And we want to make sure that we have that 100% bond that we mentioned earlier. For sheet and joint treatment, there are a variety of different options. You have your tapes, as we mentioned earlier. On the top left is the example of the peel and stick flashing tape that can be used. Do note that if it's a plywood substrate, this is the method that you do need to use as opposed to a liquid joint filler. In the middle is an example of a liquid flashing option. These are really good options, especially if they're tying into the actual window flashing utilizing the same product. And then on the right, we have an example of the mesh that was integrated with the actual air barrier material before they actually finished with the primary membrane. For expansion joint treatments, it's not as simple as just striking it flush with a appropriate liquid filler. In some situations, we may have to have a specific joint filler or insert a Balca rod at that expansion joint, finishing off with a strip of flashing peel and stick, and then having the primary membrane treat the edges of it, and we had the full encapsulation and effective seal. For rough openings, we simply want it to be 3 inches onto the wall, and 3 inches into the opening, those need to be treated with the appropriate flashing materials. When we have them going 3 inches into the opening, this is going to in turn help us make sure we protecting those openings, whether it be wood or steel. And it's also going to be a way for us to help channel water out away from the building. Also, for the metal lintel that I mentioned earlier, pretty much just reiterating what I said earlier. In a lot of cases, we'll still encapsulate the head there, but in this situation, we're showing a piece of peel and stick transitioning on the lintel, finished off with the primary membrane shingling on the top. So for rough openings, we can treat them with different options. In this case, we have a self-adhesive peel and stick membrane being used to treat the opening. As you can see on the right, we have all the overlaps of that membrane being treated with the appropriate mastic or termination sealant. And then on the left, we can see that the primary membrane is being spread across the edges of it. Do note that you don't have to use the primary membrane to encapsulate all of the flashing going in the opening, but we at least want to make sure that we do treat the edges to prevent any potential uh, infiltration at the edges of those flashings. But we also have liquid flashing options. Really a good option if you want to eliminate the amount of accessories needed, especially when you think about primers that had to be used to adhere the peel and stick and all the termination sealants that they use to treat the edges. These are a good option as they provide pretty good simple sequencing, especially when you think about using the same product for the sheathing joints as well. When it comes to workmanship, we have to make sure that there is no damage to any materials. And it's not just a matter of the air barrier itself, it's all the systems that the air barrier is coming into contact with. If the sheathing on the left is very damaged, and so we're not going to have a good finished product because the air barrier is only going to be as good as the substrate it's installed to. And on the right, this is a really good example because in some situations, we may have a perfect installation of our flashings, our transition membranes, and we're good to go. But then somebody above who is deciding to weld, well, you get enough sparks flying down at those membranes, they will damage them. And you have to think about safety at that point too, because a lot of these peel and stick membranes that are going to be used for transition are going to use solvent-based primers. If a bucket of the solvent-based primer is opened up at the bottom and somebody's welding, be prepared because there could be some litigation should a fire hazard occur. Also, we want to make sure that we have a smooth and clean application of these materials. The top let's a good example of someone trying to treat the edges of the flashing, but because it's not very clean, it may be easy to miss areas that we didn't treat appropriately. And if they have wrinkles in these membranes, that just creates a new access point for moisture to creep in, especially at the fish mouths. And over time, it can just come disadhered anyways. Also, very bottom, when we mentioned spraying over those brick ties, do note that we want to get behind them as well. If we miss them, then we have jeopardization in the continuity of the membrane. And for UV exposure, every product will have its limits. There are some products that can be exposed for 30 days. There can be some for 6 months to a year. There are some products out there that can be exposed indefinitely. But if we have a product that's for a large scale project, but we can only be exposed for maybe 30 days, well, that's when we start seeing alligator cracking in this product because we didn't get it covered up in time. Alligator cracking is shown there on the right. And with this type of material, you're going to have to see a situation where we either start over or we install more material over the top of it, rendering the first coat useless. So in summary, air barriers are the essential part of a building's energy savings and durability. We do want to select materials and systems based on project requirements and its hygrothermic region. The installation does need to be addressed during the design stage, as well as all factors need to be considered. Performance of an air barrier system is going to be dependent on the details, but it's also going to be dependent on the conditions that we present them in. Consider materials and systems that do save time and improve the installation. And we want to make sure that ultimately that we're all working together to make sure that we provide a good product for our owners.
Thank you so much, Nick. That was an excellent presentation. I really appreciate your time in presenting. Thank you, everybody, for attending. We have a couple of minutes to answer some questions now. And as I mentioned earlier, you can acquire the presentation by emailing us info@wrmeadows.com. Of course, this concludes the AIA portion of the presentation. If you have any specific questions, feel free to jump in now. We did get a few, and like I said, chiefly, where can we get the presentation? Again, info@wrmeadows.com. And again, thank you, Nick, for a great presentation. Really appreciate it. That's a wonderful introduction to air barrier systems. So the first question that I did receive that I want to throw out here, and I know that you did cover it in the presentation, but maybe just to discuss it again quickly as it came up. Could you address air and moisture control of brick veneer anchors, again, in a wall assembly like the one that was shown in the presentation?
So when we talk about the moisture control as it relates to brick and the brick ties that go through the wall, simply put, with any tie that's going into the wall, that is a new penetration into our building envelope. And so they do have to be addressed. And there are a variety of different methods of how we address this. For the sake of scheduling, this is when if we have brick ties installed directly to the wall prior to the actual membrane, they'll go ahead and just use a fluid applied to spray over every bit of it because it's going to effectively seal them. But in some situations, we may see penetrations that will come after the membrane's already been installed. And if that's the case, especially if it was a fluid apply membrane used, they'll have options of gasketing those penetrations. And one way to gasket them is you can wet set these ties into the appropriate liquid and then install them. You can have a strip of a peel and stick flashing installed behind these ties and treat the edges of them appropriately. And another method that we may see, and it's really a good effective method, is they'll go ahead and use gasketed ties as well. That's a rubber gasket that's used, which doesn't require any other type of detailing around it. So that's one thing we may see. Does that answer the question appropriately, Isaac?
Yeah, I think that was a great answer, actually, and well covered in the presentation as well. That was something that came in a little earlier. This one is a little off the cuff, and again, if you'd like to discuss it, or we could email the participant privately, I just want to put it out there. Their question is, do you recommend paying the premium for ABA certified inspectors during installation?
Well, one thing about it is we do have the Air Barrier Association of America, and there are a lot of contractors out there that are going to be qualified ABAA members. And with that, those are going to be contractors that are typically going to be well trained. But also note that with manufacturers of air barrier products, they do offer trainings for these installers. And there's a lot of times in the construction documents, we'll see inclusion of the fact that any air barrier installer that is going to be utilizing whatever system selected, they do have to be trained by that manufacturer. And so you can think about the idea of them being qualified, but if we do include the fact that whatever air barrier installer is bidding for the project, we can include in those documents that they do need to be trained by the manufacturer of these air barrier materials as well.
A great point. I really appreciate your answer there. There's another question that just rolled in, and then I think we're going to wrap this up and answer the rest or any further that do come in via email privately. But thank you again, all of you that have joined today for the presentation. I appreciate your time. This last question says, is there a cost comparison and or a system or options comparison that we can use as a reference when selecting a system?
Well, I think the best way to really explain that is it depends because we typically, as manufacturers, we're working with the contractors directly who are bidding with the materials. And so with cost comparisons, we're providing them to them. But if we need a general idea of where we may save on cost, We don't have, I would say, a resource that provides the idea of what can do a cost comparison. But what we do try to do, or with any manufacturer really, is that we like to communicate. Whether you be an architect, engineer, consultant, we like to try to get in some of these meetings where we can discuss where we may see a cost benefit of one material over another. And that's not just for the air barrier itself, it's for the entire system. And I think one really good example of that is situation where we see maybe a big plywood structure, and they may ask, should we use a fluid applied or a sheet applied? What's going to be most cost effective in that situation? And I may make the argument that, well, it depends. If you're using a permeable membrane, maybe it's better to use a permeable sheet membrane because you're not going to have an accessory with a primer. And you're also not going to have to worry about all the added accessories from a fluid applied membrane that are going to be able to treat some of those irregularities that come from plywood, such as cracks, all the screws, nails that are being punched in staples. And so that may be a situation where we may be able to say, we believe we can outline a better cost benefit using this material compared to that material. So I hope that answers the question. But yeah, that's kind of the best response I think I can provide for that.
Agreed, and I think one of the best methods to get into the weeds with this, so to speak, is to get in touch with your manufacturer partners, your sales reps and product reps, and discuss the project, the time of year, the type of project that you're pursuing, and there's not one system that's right for every single project. So obviously, exploring all of the options with your manufacturer partners can be assistive in finding a cost benefit. So I just want to thank Nick again for a great presentation. I want to thank all of our participants today for joining us. And with that, I'm going to say have a great rest of the day. Again, feel free to email us info@wrmeadows.com. I would encourage you as well to take a look at our website. A lot of resources, a lot of information available for the AEC industry as well as owners. Look forward to you perusing our website at your convenience. It's very well laid out and easy to look through our divisions of product, and that's www.wrmeadows.com. Again, any questions that you have pertaining to this presentation or anything else you would like to have us answer, please email us info@wrmeadows.com. And again, thank you so much for your time and attention today. We do appreciate you joining us and look forward to the next presentation. Our public AIA presentations are on the third Thursday of every month at this time, the same time, for free AIA HSW credit. And with that, we'll say have a great afternoon and thank you again for your time. Take care.